Hello and welcome to SudoKanard. We're here to solve this puzzle titled 857 by Australian author ChocChip, who is a regular of the channel. And this is an XY differences Sudoku, this variant that was created by Glam Hippo, and of which I made a puzzle in the recent Sudoku Grand Prix. And this was the inspiration for ChocChip to make this puzzle. So the rule is that whenever you have such a symbol between two cells, it means that the difference between the corresponding digits is the value at the beginning of the row or the column, and all such possible clues are given. I haven't solved this puzzle prior to this trial, so I hope it will go all right. Well, such a chain of equal differences can only be done with difference of 1. So those are consecutive digits from 2 to 8 or from 3 to 9. So the missing digit here must be 2 or 9. And those here must not be consecutive. So if this is the 2, then we have 3, 2, 3, 4, 5, 6, 7, 8, 9 in this order. And if this is 9, then this can't be 8, so 8 must be at the other end with 7, 6, 5, 4, 3, and 2. So we get pairs along the column. So that's the first thing. Now, where can we look? So here we have two chains like this. So the value of the difference can only be 2 or 3. 4 would work with 1, 5, 9, but that's the only place, the only way you can have a chain of 3 digits with differences of 4. So 2 would make this 3 and 5, and 3 will make those 4 and 7. Oops, not here, but there. I think the question would be, what would work here if this were a 3? If I remember correctly from my puzzle, with 1, 4, 7 here and a 3 there, this would have to be 2, 5, 6. No, 2, 5, 8, sorry about that. And that's interesting because if this is a 2, then this is a 5. If this is a 3, then 5 goes there. So this is never a 5, and this gives us the orientation of what goes into this middle column. Yes, that's interesting. So if this is a 3, then this will be a 9. What happens if this is 2? If this is 2, I think it just doesn't work. Because I can't put 3 even digits, I don't have as many of them. So I must put 3 odd digits here and 3 odd digits there. That doesn't work. So this is actually a 3 with a 4 and a 7. This is 5 surrounded by 2 and 8, and 9 at the other end. Nice. 4 is interesting here because 4 puts a lot of constraint on what you're putting here, because 4 is a rather central digit in the list from 1 to 9. So the differences we can have with 4 are capped by 5, which is the difference between 4 and 9. So this is at most 5. Obviously, it's not 4. it's not 3, so it's from 1, 2, and 5. 1 would turn this into a 5, 2 would turn this into a 6, and 5 would turn this into a 9, which is not saying that much. Apart from what I've already used, there are not that many big streaks of digits with the same difference. Here, any digit could work, well, except from those digits, except from 1, except from 6 because of that. So not that many digits, actually. Let's just ponder. 3 would work with a 6. 4 would work with a 5. And conversely, 6 wouldn't work. 7 would work with a 2. Well, that's 4 options, actually. That's not so interesting. This is definitely not the place to look. One thing I mentioned in my video is the fact that the places for 9 on the first row and the first column are constrained because you can't have a 9 on a row where you have such a separation, because 9 is not the difference between 2 digits, so you can't have a 9 here. I will perhaps use some coloring. Let's say, so 9 could be at the beginning of this row. 9 could be at the beginning of this row and this row also. That's a lot, actually. It could be here. It could be here, not here because of this 9. So that's still a lot of options, actually. So perhaps not the place to look. Well, this row looks suspicious because we have 3 instances of the correct difference. So what can it be? It could be as high as 6. So let's ponder. 1, 2, 4, 6. How would 6 work? 6 could be 7 minus 1, 8 minus 2, 9 minus 3. So we would have 2 and 8 here. Seven wouldn't work here, so that would be 7 and 1, and that would be 9 and 3. And this would be a 4. Actually, 4 is not allowed here, because 4 here would turn this into a 2 or a 4. And neither of them would work. 2 and 4 would make this a 2. That doesn't work. Or perhaps I just spoke nonsense. That wouldn't be a 4. Let's try this. If I put a 6 here, then... Oh, yes, that's correct. 4 would have to be here. 4 wouldn't be in a difference. So that doesn't work. This is not 6. What about the difference of 4? So we don't... I think it doesn't work because wherever I put 1 or 9, it comes with the 5. So 1 and 9 are not in those dominoes, so 1 and 9 must both be in this domino. So 4 is not an option. So we're down to 2 options, 2 and 1. What about 2? If I try to put a 2 here, then every time I have digits with the same parity. So I must have 4 odd digits and 2 even digits, and then this is an even digit. So let's ponder that. This will be an even digit, namely 4 or 8. 8 would work here with the 6. That seems to be an option. With something like 7, 9 here, 1, 3 here, 6 and 4, it totally seems to work. So 2 is definitely an option here. Let's try with 1. If I put 1 here, then I'm seeing that 4 doesn't work next to the 5. 4 is not here, so 4 will be somewhere here, but it should be accompanied with 3 or 5, and this doesn't work. All right, so this is actually a 2, with 8 and 2. And now I must begin my former reasoning again. This, so I was saying, I have an even number of each parity. So I will have 4 odd digits and 2 even digits somewhere. So this must be even. 4 here would put a 2 there. It doesn't work, so it has to be 8 with a 6 there. So 6 is removed from there, so that's not a 2. Actually, it couldn't be a 2 because of that. So now I must have 4 and 6 somewhere. I must have 9 and 7 somewhere. 7 doesn't work in here, so 7 and 9 are here. So now 4 has to be here by Sudoku. That's a 3, and that's a 6, and that's 1 and 3. All right, here now I must have 1, 4, and 6. And here I must have 3 and 9. So this should help. What are the possibilities here? 9 doesn't work with any of them. So that's a 3. That's a 9. 3 with a 6 would have a difference of 3, which is not allowed. 3 and 1 would have a difference of 2, so that's 3 and 4 with a difference of 1. That's a 6. And that's a 5 with the 9 here. All right, this is coming together. That's an 8 for the difference of 1, and those are 2 and 5 in some order. So we have 1 and 4 somewhere here. This is from 5 and 7. None of them can be excluded by looking at this 6. Here we must have something from 1, 4, 5, and 7. We just know that 1 and 7 are not next to each other. What could this be? The difference between 6 and another digit is at most 5. This is from 2, 3, 4, but 3 is not available because this would have to be a 3. 2 wouldn't work because we would need a symbol here. So that's a 4, and this is a 2. So this is from 7, 8, 9. Now, this is from 6, 7, 8, 9. That's certainly not worth pencil marking. So the digits here, the options are from 2, 7, and 8. And with a difference of 5, this is from 2, 7, and 3, which is not so interesting. Now, what about this difference? There are not so many positive clues that we can use. So what are the options? It's not 1, 4, 6, and it's at most 7. So it could still be a 2. No, not a 2, because it would put a 6 into this cell. Perhaps a 3 with a 5, 4, or a 5 with a 3, or a 7 here with a 1 there. Yes, that's correct. The options for this cell, the candidates, just by looking at Sudoku, are 4, 6, 7, 8. But some of them can be removed at once. 7 and 8 would put a 1 or a 2 here, which would break. So we're left with 4 and 6, which means 3 or 5 here. There's still some work to do. There's still this that I can use, and I'm seeing that there's no symbol here, so this is not 8. So this is from 2, 5, and 7. Now 7 would put a 2 here, which is not possible. So we are left with 2. 5 would put a 4 here, so that's it, a 2 actually. And this is not a 2, so this is not a 7. With 2 here, this is 7. So this is 8 and this is 3. That's not 3, so that's not 5. Oops, sorry about that. That's not 5. Not 5. Now this 3 on this row can only be here, which means that this is not 9. I can remove this coloring. This is actually a 5 and this is 7. So that this is 3 and this is 6. And this here can now only be a 6. We are left with 1, 4, and 5, and I don't think any of them would cause any issue with this 6 and the negative row. This column still needs a 4, but 4 here wouldn't work because of 2 and 6, so 4 is here. So this is 8 or 9, this is 7, 8, or 9. Well, I'm not out of the wood. This 2 now goes somewhere around here. That's not 4. That's not 6, so 6 is somewhere here. Five is somewhere down there. Oh, there's a 4 here, so 1 here won't work because of the 5. So this is 5, and this is 1 or 9. We need a 6 here. And this is a 1 actually, with this 3 here, so that this is 9, and this is a 3-6 pair. So this 7-9 pair is resolved. That's not the 9. So we're left with the options of 9 in this corner or 9 in those two places. This is from 5, 7, 8. This is from 5, 8, and 9. Not so interesting. 8 and 1. So this is 7, actually. And now the first column needs the 7 down there. This row needs 1, 2, 6, and 7. 7 can only be here. That can't be a 2 anymore because we would need a symbol here. That's the 2. 1, 2, and 6. So this is from 1 and 6. And note that 1 and 6 can't be next to another because of the 5 and the lack of symbol, but we know that because of this actually. And 6 is nowhere here in this column, so that's the 6 and that's a 1. Now this column here needs a 5 and a 3, so that's 5 here, 3 there. This is 1 and 8. And an interesting point is that 8 here would put a 1 there, which would break this 7 here. So this is like this. Here we have a difference of 7, which doesn't break. This row still needs a 7, which can only be here, and a 2 and a 4. In this order, necessarily. This column still, or here. I need 5, 8, and 9, so this is not 8. And this is not 9, because we would have a difference of 7. So this is 5, the 9 is here, that's 8. So finally 9 is not here, 9 is in this corner. This is 8. Remove the coloring, so this is 5, this is 8. And we have 1, 2, and 1, and 3, and 6. 6, I said, and 3. And let's finish with 4 here, 9 there, and 6 here, and that's it. This completes this very nice puzzle by ChocChip of XY differences Sudoku. I think it's definitely more difficult than my puzzle, but then I was doing something for Grand Prix, so it had to be in the approachable spectrum. Not that ChocChip's puzzle would be unapproachable, it just needs more, I think it just needs more reflection, which is fine. Thanks for watching this video. Thanks Adam for this puzzle. See you on SudoKanard.